Just hit a button, Morty. Give me a beat.
Oh man, okay, alright,
What up, Berry Bears? This is your favorite coach that does the most, Coach Givens. What? And today we are going to do part 2 of scientific notation. This week we're going to focus on super small numbers. So without any further ado, let's jump right into it. Alright, so a quick review about what scientific notation actually is. It is a special way to write numbers. Special way meaning it's an abbreviated version of super large or super small numbers. It's used with the base 10 format, which means we multiply times 10, and it usually has an exponent. So last week we focused on super large numbers. This week we're going to focus on super small numbers. Just a quick recap. Last week we started with this number, 700 in standard form, and we turned it into the same value but in scientific notation. So 700 in scientific notation is 7 times 10 to the power of 2. If you remember, we had a couple of different parts. The coefficient is the number, the leading number. It must be between 1 and 10. Base 10 means we're going to multiply the coefficient times 10, so times 10. And then, of course, the exponent in this instance is 2 because we would have to move the decimal to the left twice to go from 700 to 7. So you would read it as 7 times 10 to the power of 2. But you remember that already. So let's kind of focus on what super small numbers are. All right, so when the number is smaller than 1, the decimal point has to move to the right. So the exponent is negative. I'll say it again. The decimal point moves to the right and the exponent is negative. Sounds a little weird, but don't worry, I'll hook you up. All right, so let's go back to 700. 700 is more than 1, so we need a number that's smaller than 1. So let's switch that booger out to, let's say, 7 thousandths. All right, here's the number, 7 thousandths in standard form. In order to turn it into scientific notation, the foundation remains the same. 7 times 10. Remember, your coefficient has to be between 1 and 10, so we would move the decimal to the right in order to turn 7 thousandths into 7. So the base is the same, times 10, but since we're moving the decimal to the right, it changes the exponent just a little bit. In order to figure out what the exponent is, we count the number of places we have to move it to the right. So in this instance, it would be 1, 2, 3. So we move it to the right 3 times, and our exponent will be negative. So 7 thousandths in scientific notation is 7 times 10 to the power of negative 3. 7 times 10 to the power of negative 3, because we moved it to the right 3 times. All right, so let's try a couple of examples. Single grain of rice weighs 0.029 grams. So the number we're working with is 29 thousandths. See, tenths, hundredths, thousandths. So 29 thousandths. In order to switch it to scientific notation, we use the same foundation, so our coefficient has to be between 1 and 10. So we drop the decimal between 2 and 9 and keep the base 10 format. Yeah, I know, it sounds very complicated, so here's what it looks like. 2.9 times 10. Now we have to figure out the exponent. In order to do that, we need to move the decimal to the right. So 1, 2. So we only need to move the decimal to the right twice this time. So our exponent will be negative 2. The way you read it, 2.9 times 10 to the power of negative 2. Cool. All right, let's try another one. A grain of sugar weighs approximately 0.000625 grams. All right, so this number clearly is in standard form, 0.000625. And in order to set it up in scientific notation, we use our foundation, 6.25 times 10. Now we have to figure out the exponent. So we count the number of places we move the decimal to the right. 1, 2, 3, 4. Notice that we stop between 6 and 2 because remember, our coefficient must be a number between 1 and 10, and 6.25 is between 1 and 10. So we move the decimal 4 times to the right, so our exponent will be -4. And the way you read it, 6.25 times 10 to the power of -4. Oh yeah, we're rolling now. All right, here's another one. The mass of a grain of salt is approximately 5.85 times 10 to the power of -5 grams. Okay, so they flipped the script on us on this one. We're starting with this number in scientific notation. Now we got to move it around to standard form. So, I don't think I want to explain this one. Let's just see if you could figure it out. I'll give you a second. Here's a hint. To go from scientific notation to standard form, you move the decimal in the opposite direction. All right, so if you move the decimal 5 times to the left this time, you should have got 0.0000585. Yeah. Did you get it right? Okay. Okay, so I've shown you a few. Why don't you try a few on your own? You can try 3. Here's the first one. 0.06 or 6/100ths. Represent 6/100ths in scientific notation. Don't worry, I'll give you a second. Did you get this? 6 times 10 to the power of -2. Yep, we moved the decimal twice. So -2 is our exponent. All right, here's another example. Ooh, 0.000000786. Remember, your coefficient has to be between 1 and 10. So drop your decimal between 7 and 8. So it should be 7.86. That's all I'm going to help you with. Oh yeah. 7.86 times 10 to the power of -7. I got a good feeling about this, guys. I got a good feeling about it. All right, here's the last example. Ooh, so now we're going from scientific notation to standard form. .0067. Tenths, hundreds, thousandths, 10,000ths. Okay, 67 10,000ths. That's all I have for you today. Hopefully you understood it. If you have a question, don't hesitate to reach out. I mean, we're here to help, right? Send an email, leave a comment in Google Classroom. Feel free to YouTube it, Google it, ask your parents or an older sibling. Like, the options for help are endless. Until next time, I'll holla.